Hello everybody and welcome to today's LiveCode Global Advanced course talk. My name is Michael McCreary and I'm a developer here at LiveCode. I've been working for the company for over 10 years now. Today's talk is called Understanding and Using REST APIs. So what will we cover today? We'll go over what is a REST API, some examples of REST APIs and how to use them, how to integrate a REST API using LiveCode, as well as walking through a work example of integrating a REST API using LiveCode. It's important to note that what we won't cover today is how to build a REST API using LiveCode. That's a completely separate topic, but is completely doable using the LiveCode server engine. I mentioned that we'll be walking through a worked example. And here's a quick preview of what we'll be creating. This is a stack that wraps Stripe. Stripe is a service similar to PayPal, which allows you to, amongst other things, charge customers credit cards. So here we've got a list of customers, and for example, you can choose to add a new customer, specify their name and email address. You can look at an existing customer, update their details, see all the credit cards they have, add a new credit card to their account, look at all the payments they've made in the past, and create a new payment. So this is all done using a service called Stripe, as I mentioned, and Stripe provides a REST API which provides all these facilities. So in the latter part of this talk, we'll go through how we wrap that REST API to get all this functionality. But before we can begin walking through our work example, we need to understand what is a REST API. REST APIs are a common standard used by web-based APIs. REST here stands for Representational State Transfer. Now, I wouldn't worry too much about the acronym. I had to look it up myself in Wikipedia. Web APIs provide client apps, in our case this is going to be our LiveCode stack, access to cloud-based services via HTTP. REST is a software architectural style that's used to advise API developers rather than a hard set of rules that must be followed. So we can think of this as sort of a set of design principles that will help API developers create a standard and well understood API rather than a rigid set of rules that define exactly how the API is to operate. So a few examples of REST APIs. Facebook offers a REST API that allows you to access elements of a user's profile. So this is useful if you say want to log in using Facebook and then pull the user information rather than having to store all that information on your own local DBs. You can just access the information that the user has already in their Facebook profile. And similarly, you can automatically create new posts. So that's useful if you have an app which wants to automatically post to the user's Facebook wall on particular events. Google, they provide access to several of their AI services via REST APIs. So for example, their image recognition tools and their text-to-speech tools. That's all accessible via REST APIs. And Skyscanner, they're a travel company and you can use their REST APIs to query and book flights and hotels. So I mentioned that REST is based around a set of principles. What are those principles? Nouns are used in the HTTP URL to provide access to a resource. So for example, /users, your users be the noun that provides access to all the users, /flights, and access to all flights. Look at our Skyscanner example. And /users/123, that gives you access to a specific user. So here, 123 is included in the URL. That's the ID of the user that we want to access. And the specific nature of the request is controlled by the HTTP verb used. So those are get, post, patch, delete. You've probably heard of those before. But if you want to list all the users, you can use /users and the HTTP verb would be get. And if you want to delete a specific user, the HTTP verb would be delete, and you do /users/123, so that would delete the user with ID 123. URLs will be nested to provide access to sub-resources. So if we want to access all the addresses of users 123, you can see in that example there, /users/123/addresses, and that would return the list of user addresses that are mapped to that user. Don't worry too much about the specifics of this quite now. We'll expand upon it later. Further principles: use a standard encoding when sending data to and from the server. This is typically JSON. This is just the means to encode the data that's transferred between the client and the server. Use standard error formats based around HTTP error codes. So when the server returns an HTTP error code of 200, that's typically a success, and 400 error codes, so 401, 404, 403, 422, for example, those are all error codes that suggest something's gone wrong. That's a fairly standard in REST APIs to use those error codes to indicate specific errors. A stateless API, each request is independent of any previous requests. So essentially what that means is every request is brand new. It has no memory of what's gone before, and also provides no information as to what happens in the future. So we can see that REST uses HTTP. I'm sure quite a few of you will be reasonably experienced with HTTP, but we'll just go over it briefly. HTTP is the protocol used to fetch web pages. So when you navigate to livecode.com, your browser is sending a GET HTTP request to the LiveCode web server asking for the contents of the LiveCode homepage. Now, it's typically used for fetching web pages, but we can see how REST leverages this to provide APIs. But first, let's go over HTTP a little bit more. So you can think of an HTTP request being in two parts. The first one is the request itself that the client sends to the server, and then the response that the server sends back. So first, let's look at the request. Each request has a URL component. This is typically the web page on the server you want to access. So the LiveCode global page is livecode.com/global. Here, global is the URL component. Additionally, each request has a method. That's the verbs we were talking about earlier. Get, that's the standard method used to fetch a web page. Post, that's used to send information to the server, such as a sign-up form. Put, a lot less common, but it's used to replace a resource on the server. Patch is similar, used to modify a resource. And delete is used to remove a resource. Now, get and post, those are the ones that are commonly used by web pages, and that's what your browser will implement. Put, patch, and delete are much less common, but they're very useful in REST APIs, which we'll see later on. So in addition to the URL and the method, each HTTP request has a set of headers. Headers are just key value pairs that are used to attach additional meta information to the request. So for example, each time you request a web page with a browser, your browser will tell the server the specific nature of the browser. So if you're using Chrome, it will tell the web page that you're using Chrome. If you're using Safari, it will say Safari, similarly Edge and such. Each request also has a query string, which is used to pass additional information to the server. So an example there, google.com / search each with LiveCode. That's passing an additional search string to the Google server in the query string. So anything that's after the question mark, that's the query string. And again, those are similar to the headers, and they're key value pairs, with times separated by equals. Requests can also optionally have a body, so that's for post, put, and patch requests, and that's used to send more involved data to the server. So we mentioned it earlier, but that's typically something like a user data from a sign-up form, things like that. So the other part of the HTTP process is the response sent by the server. Now each response has an associated code. 200 error codes suggest that the server processed the request successfully and everything has gone as expected. 300 codes indicate that the request has moved and essentially redirects your browser to a new location. 400 codes indicate that something's gone wrong. Those are error codes. And typically that means that the request sent by the browser is malformed. And 500 error codes are internal server errors, so that's something's gone horribly wrong in the server and they're just bailing out. And so like requests, HTTP responses also have a set of attached headers, and like with requests, these are key value pairs that detail meta information, so any cookies that the browser is to store or how long the browser should cache the response. Each HTTP response has a body, and this is the core of the response. So in livecode.com /global, the response would be the LiveCode global web page. So I mentioned that REST APIs use the features of HTTP to structure the API. So let's look at how they do that. So as mentioned a little while back, the URL is a noun used to determine the resource we want to access. So now here, users/users would return all the users/users/123, the user with ID 123, /users/123/addresses. The addresses belong to the user with ID 123. The verb in the request method determines what we want to do with the resource. So get, that's list a collection of resources or an individual resource. Post, that's create a new resource. Put in patch, that's update an existing resource. And delete is remove a resource. This is often referred to as CRUD, create, read, update and delete. So if you ever use MySQL or SQL databases, it's kind of similar. Create is similar to insert, read is similar to select, update is update in MySQL, and delete is delete in MySQL. So these are kind of the core operations that REST APIs typically provide for an individual resource. The query string in the HTTP request is used to include additional information in the request. Typically uses filtering information, so a search string to filter the results by, or pagination details. So I want to only see the first 50 resources rather than the whole set. The request body is used to pass resource information to the server. So we mentioned that the post verb and the post method is used for creating a new resource. The request body would include the resource data to create in the post request. The request headers are used to pass additional information to the server that shouldn't be included in the query string or request body. So this is typically things like authorization details or content encoding. In the response headers, they perform a similar action containing metadata information that shouldn't be included in the response body. So again, this is typically content encodings or authorization tokens. And the HTTP response code is used to relay the status of the request. So a 200 response code, that's the server telling the client that the request was a success. 201 is a special success error code that's used to suggest that the new resource has been created successfully. 400 suggests that the request was malformed. So typically that's used in the case where you send a request to the server that the server just doesn't understand, doesn't know what to do with it. 401 and 403, those are authorization errors. So 401 is that the credentials that you've been passed are not valid, and 403 is the credentials are valid, but the user defined by the credentials does not have the access permissions. 404 you've not heard of, but that's when you're trying to access a resource that doesn't exist. So for example, /user/123, if there isn't a user with ID 123, 404 would be the result code returned. 422, that's a validation error. So for example, you're trying to create a new user and say you are to pass an email address, but the email address doesn't validate, it's not a valid email address. 422 would be returned in that case. And 500, as we mentioned previously, that something's gone wrong in the internals of the server. It's not the client's fault, it's the server's fault. Typically this should never really happen, or you shouldn't see this in mature REST APIs. So we now have a basic idea of what a REST API is and how REST APIs use HTTP. So the next question is, how can we access REST APIs from LiveCode? Well, the good news is it's quite simple. REST APIs, as mentioned, use HTTP. So we can simply use LiveCode's built-in HTTP handlers that are provided by libURL. So on the right hand side, there's a few examples. The top one there is how you would pass headers to the server. As mentioned, headers are key value pairs separated by a colon. So this example there is setting an authorization header. We'll talk more about authorization a little bit, but that's just a basic example of how you'd pass a header to the server. A GET request, so the GET verb, that's simply using the GET command, GET URL. An example there is fetching a list of customers that is available via the Stripe API. And similarly, if you want to create a new customer using the Stripe API, you can use the post command. There, we create a new customer with the given name and email. Those again are key value pairs. I'll go into more detail about the specifics of building request bodies and processing request responses, but for now, that's some basic examples of using libURL. Now, LiveCode provides an additional library called TSNet that extends the standard libURL handlers with some additional functionality. The additional handlers provided added flexibility that makes accessing REST APIs simpler. So if you've ever used libURL, you notice it's a bit limited in what you can do. So the additional HTTP methods, things like put, patch, delete, they're a little bit awkward to access via libURL. Similarly, at times setting headers, getting response headers are a bit clunky. TSNet provides a much simpler and cleaner way to do that. And these features are often used by REST APIs, that's why using TSNet is a good option here. Also, TSNet provides non-blocking variants of the standard HTTP methods. A little bit about blocking and non-blocking requests. The standard libURL commands, things like getURL and the post command, those that were in the previous slide, those are blocking. This means that script execution will halt until the request has completed. This has the undesirable effect of blocking the user interface while the request is in process. So you may have experienced something like this yourself when using the blocking libURL commands, particularly if you've been using them to fetch a particularly large web page, or for example a large image, something like that. The command doesn't return until all the data has been downloaded, and effectively the user interface locks up, it freezes while that's in process. This means that the user can often be left confused and unclear if the request is still in process or possibly the app has crashed. So a good alternative to that is to use TSNet's non-blocking alternatives. TSNet provides non-blocking alternatives to the standard libURL handlers. The request call will return control to the calling handler immediately, allowing for the developer to keep the user interface up to date with a progress bar or a spinner. When the request is completed, a callback handler will be invoked. The developer can still use a linear structure in their code by using the wait with messages command. I'll explain what I mean by that in the next slide. Effectively, what non-blocking requests allow you to do is provide a much more responsive user interface. You can have a progress bar or a spinner going while the request is in process. That will leave the user much more satisfied with an understanding of what is going on. I mentioned it's possible to maintain a linear style with non-blocking variants using wait with messages, but what do I mean by a linear style? Well, if you've ever used non-blocking variants that libURL or TSNet have to offer, you'll know that you need to use a callback handler. That callback handler means that the same GET request, for example, ends up being spread across two handlers rather than one. The first handler sending the request, the second handler processing the response. Now because you're using non-blocking variants, it does free up the user interface, making it much more responsive, but it does have the downside of making your code a little more complicated. Now, it is possible to maintain this in a single handler, as I've called, using the linear style. And this is an example of how to do that. So on the left hand side, we've got a command called getRequest. You pass a URL to that, and it's simply just performing a GET request on the given URL. The important handler call here is TSNet get. The TSNet get is a non-blocking variant of the standard get URL. First parameter there is a unique ID that we give to identify the request. Second is the URL we want to fetch. The third is any headers we want to pass in the request. And the fourth there is the callback handler. Now TSNet get, because it's a non-blocking variant, returns immediately rather than waiting until the request is complete. So we can then process the response in the get request complete handler down below. So our get request complete handler will only be called once the request has completed and the response has been returned by the server and downloaded. So what we do there at the end of that handler, that's the important line, is we put T response into S request response. Now if we go back up to the get request handler, you notice the line wait until S request response is not empty with messages. So what's happening is the GetRequest handler is waiting until the request has been responded by the server, that is, until the request complete handler has been called. So what this has the effect is that the GetRequest handler does not return until the data has been returned from the server. But because we're using wait with messages, everything is still effectively non-blocking. That is, the user interface is completely freed up and you can display progress bars, spinners, anything like that to keep the user up to date. On the right hand side, we can see an example of how you can use the new GetRequest handler. Effectively, the GetRequest handler provides the same functionality as our standard blocking get variant, but it provides effectively a non-blocking experience. So the user interface can still be updated with progress bars, or in the example here, a simple spinner. So let's take a quick look. So the mouse up handler there, the first thing it does is it shows a spinner group. Most likely in here you'll put a spinner widget that will spin away freely while the request is being processed. Then we call the GetRequest with the particular URL we want to use. In this example, we're just fetching a list of customers. And then that handler, that GetRequest call, will not return until the data has been returned from the server. Then the next line is pretty simple. We just check to see if the result is set. If that's the case, then it's an error. And we'll just answer that to the user. And if not, then we assume everything's successful. And then we can store the data returned from the server in our customer's data grid. And then finally, we just set the visibility of the spinner to false, indicating that the request is complete. So all throughout that experience, the spinner will have been whirring away, letting the user know that our request is in process and everything is functioning as expected, rather than the experience that the blocking variant would have provided, which would have effectively just frozen the user interface completely. Up to this point, I've mentioned JSON a couple of times, but what is JSON? JSON is a standard method for encoding data ready for transmission between the client and the server. The acronym itself stands for JavaScript Object Notation, but like with REST, I wouldn't worry too much about that. It really just refers to the origins of the encoding. JSON allows for complex data types such as objects and arrays rather than just plain text to be communicated. So for example, this lets you send arrays up to the server in a method that the server knows how to decode and understand. JSON is the most common method that REST APIs use for encoding data. When working with encoded data, it's standard REST practice to set a few headers to detail the encodings used. If you want to tell the server to encode its response as JSON, the accept request header should be set to application/JSON. If you're including a body in your request and you're encoding it using JSON, you can set the content type request header to application/JSON. And similarly, if a REST API returns JSON encoded data, the server will confirm this by setting the content type response header to application/JSON. These examples all use JSON as encoding, as this is the most common standard used throughout REST APIs, but it does apply to other encoding types. Some APIs, though increasingly rare these days, we use XML to encode the data. So in this case, you need to use application/XML, but the same principles apply. But how do we actually use JSON with LiveCode? Well, fortunately, LiveCode provides a library called MergeJSON. MergeJSON makes JSON easy to use in LiveCode. MergeJSON removes the need to worry about the specifics of the JSON encoding. We can instead just deal with LiveCode arrays. MergeJSON can convert a JSON blob to and from a LiveCode array. Array to JSON is a function that you can use to convert a LiveCode array into JSON ready for sending to a REST API. A JSON to array is a function which you can use to convert a JSON response from a server into a LiveCode array. The final part of REST APIs that I want to cover is authorization. Most REST APIs will have their access restricted by some form of authorization, but there isn't a standard method that all APIs use. As I mentioned at the start of this talk, REST is really just a set of design guidelines rather than a set of hard principles that must be adhered to. But some common authorization methods include using HTTP basic auth, requesting an access token, and OAuth. Now, OAuth is an open standard for access delegation. And I won't really go into much detail about that. It's sort of worth a whole talk in itself. But it's worth bearing in mind that it's one method that REST APIs often use. So, HTTP basic authorization. HTTP basic authorization involves encoding a username and an optional password in the authorization request header. Now, because you're sending a username and password, this should always be performed over HTTPS. Sending it over a plain unencrypted connection leaves all sorts of security hazards. The username and password are base64 encoded and separated by a colon. So in the example code below, we're just setting the HTTP headers to authorization and then base64 encoding the username and password. Another option that's commonly used is to authorize by a token. If an API offers authorization by token, typically there will be a specific endpoint used to generate a token. This endpoint will be called with a username and password, returning a token in exchange, which should then be included in all future requests. And as with basic auth, this should always be done over HTTPS. Sending a username and password over a plain unencrypted HTTP connection is asking for all sorts of trouble. So an example of authorization by token, here we're posting the username and password that's used to access the API to the tokens endpoint there. And then that tokens endpoint, if successful, should return the access token that can then be passed through the access token header in all future requests. The name of the header depends upon the specific API. Each API will do it slightly differently, but effectively what you've got through the tokens endpoint is a means to generate a token based on a username and password, which can then be used to authorize all future API requests. Hopefully by now we've got a basic understanding of what a REST API is, the principles that define them, and how we might begin integrating a REST API into a LiveCode stack. Now, as we mentioned at the beginning, we're going to do just that and walk through integrating the Stripe API into our LiveCode app here. Now, Stripe, as we mentioned, is a payment processor, much like PayPal, where we can take customers' details and bill their credit cards. And first of all, let's take a quick look at our simple app and the features that we have integrated. So here in the first card, we can see we've got a list of customers. Click the little plus icon here and choose to add a new customer. Let's add Panos in, adding his name and email address. And then click create. A little spinner appears and now we see Panos in the list here, and we can also choose to filter our lists. So we can filter by email. And then you can see Panos displays there. Obviously we've only got 2 in there, but if there were more customers in there, that would have been a more useful feature. If we double click on Panos, we can choose to edit his details. So let's say we update his email address. Update that, and now his new email address is there. And similarly, we can choose to add a card to Panos' account. We're currently running in the Stripe in its test mode, so we can just use a dummy card detail there. Add that card. And now that wee card appears on the list of cards mapped to Panos, and then we can choose to bill Panos' card. Let's make a payment. In euros for 100 euros. And then we can see that we billed Panos 100 euros. If you decide to integrate Stripe yourself, you'll first of all need to sign up. They've got a simple sign up form on their website. You just need your name and email address. Once you've got your account set up and verified, you can then log into their dashboard, and it should look a little something like this, which has all your various bits and pieces and details. And sort of an important section down on the left hand side is the developer section, where you'll be able to see the API keys that are necessary for integrating Stripe into your LiveCode app. But before we can get started with the integration, we need to understand a little bit about the Stripe REST API itself, how it functions and how it adheres to those REST API principles that we talked about earlier. To do that, let's take a quick look at the Stripe's REST API docs. Now they're available at stripe.com/docs/API, And if you've ever looked at a REST API doc before, you'll notice they all have quite a similar layout. They have a left-hand navigation bar which lists the individual resources that the API has to offer, as well as an introduction section. Then the main body of the doc itself is split up into two columns, with the core docs information being in the left-hand column, and then on the right-hand side they have code examples in an assortment of different programming languages. Now, unfortunately, they don't have a LiveCode integration, but we can create our own one using the details in the docs. So let's take a quick look at the first paragraph in the introduction section. The Stripe API is organised around REST. Our API is predictable, resource-oriented URLs, accepts form-encoded request bodies, returns JSON-encoded responses, and uses standard HTTP response codes, authentication, and verbs. Now that tells us quite a bit of information that's quite important to us. First part here is accepts form-encoded request bodies. So that tells us is how the Stripe API expects any data sent from the client, that is our LiveCode app, to be encoded. And in this case it's form-encoded. What that means is it's key value pairs, that is key equals value, and then each new pair is separated by an ampersand. So that's fairly straightforward to do from the LiveCode perspective, and we'll take a look at how we do that when we get into the integration. Next part here is returns JSON encoded responses. That tells us all the information we get returned back from the server will be encoded as JSON, and as we discussed earlier, we can use merge.json to decode that into a LiveCode array. And then the final part here is uses standard HTTP response codes, authentication, and verbs. So let's first of all look at authentication, which we can navigate to down the left hand side here, authentication. And the interesting paragraph for us here is authentication to the API is performed via HTTP basic auth. Provide your API key as the basic auth username value. You do not need to provide a password. So we touched upon HTTP basic auth a little bit earlier. All we need to do is set the authorization header and include the username and password, and Stripe tells us that the username is our API key and the password is empty. The API key, as I mentioned earlier, is available from your Stripe dashboard. It's under the developers section, and if you look at this paragraph here, it's the SK test, secret key test, and the secret key here is blurred on my account, but you can use your own secret key for your integration. If you're using a live Stripe, a live Stripe account, then you can use your live secret key, but we're just using the test account for the moment, so we'll use our test secret key. And then the final part that we're interested in is errors. We mentioned in our REST basic principles section that you should use the HTTP status codes to indicate the success or failure of a request, and that's exactly what Stripe does. This little table down the right hand side details the response codes and what they mean. As per most APIs, 200 response code is success, 400 response codes indicate something's gone wrong, there's an error, and it details the individual 400 codes and what they all mean, and then 500 error codes suggest something's gone wrong on Stripe's side. That is an internal error on their behalf and something that we can't really do anything about, but we do need to handle the 400 error codes. And each 400 error code will have an error body. That's something we talked about in our basic principles. So we know that this will be a response from the server, so it will be JSON encoded, and then we can then use merge.json to decode it into a LiveCode array. And the LiveCode array will have these, as we can see the attributes, these individual keys. So it'll have a type, which will be the type of the API, the type of the error, the individual error code, which is specific for each request, and then these further keys. Probably the most interesting one here is the message section, which is a human readable string, which we can then use to handle, possibly display that to the user or handle the error as appropriate. Armed with this knowledge, we can now begin to make a start on our LiveCode integration. The first thing they did here was to create two library stacks, one named LibRest, the other LibStripe. These library stacks would provide a suite of utility handlers that our main UI stack would access, allowing us to communicate easily with the Stripe REST API. The first library stack here, LibRest, provides a set of commands and handlers that are generic to all REST APIs and just allow us to communicate with the REST endpoints. And then the second, LibStripe, provides a set of handlers that are specific to the Stripe API. Now the first thing you might notice here is that these are script-only stacks, and I'm currently viewing them in a text editor. There's a couple of reasons to use script-only stacks. One is that they play nicely with
version management systems such as Git, but also it means that they're easily editable, testable, and shareable between individual projects. So these two library stacks could be used by any UI stack, and they're easily passable between different projects. So let's dig into the actual code for librest. The first handler here is command. It's titled librest configure, and it's used to set up the library for use with a specific REST API. It takes 5 parameters here. First one is the endpoint, second one is the content type, third is the accept type, and the last 2 are specific to any authorization that's done using tokens. We can ignore those last 2. If you actually look at the handler code, it's all fairly straightforward. It just puts those parameters into script local variables. But if we look at those parameters specifically, the endpoint, so that's the base URL that we use for the API. So if we go back to our Stripe docs, go back to the introduction, base URL here is api.stripe.com, so that's all we need to pass through there, and we can just store that for later use. The content type, we know that accepts form encoded request bodies, so the content type we can just specify there as form encoded, and the accept type, that's what the server, that's what we want to accept, i.e. what the server returns is JSON. So we can go back to our library there, and we can see that we can just pass through the endpoint is stripe.com, api.stripe.com, the content type is form encoded, and the accept type is JSON. So if we go to our Stripe library, we can see that here when the library stack is called. That is when you call start using for the stack. Library stack message will be sent, and then we can call librest configure, passing through api.stripe.com v1. We're using the first version of the API. Form encoding for the content type, that's how we encode the information sent to the server, and JSON for the accept type, that is how we expect the server to return the data. And as I say, that's all fairly straightforward in this handler. It just stores those in script local variables for use later. And the second configuration handler that we're interested in is librest set credentials, and here we pass through 3 parameters: username, password, and token. And exactly like the configure handler, these 3 parameters are just stored in script local variable. The username and password are what we're really interested in. Here we're not using token authentication with Stripe API, just this username and password. And indeed it's just a username. If you remember from a little earlier, the authentication is using the HTTP basic auth, and we just pass in our secret key as the auth username. So if we go back to our Stripe library, which calls that on library stack librest set credentials, we pass in our secret key, which is just a constant. You can enter your own Stripe secret key there as a username, and you don't need to pass a password. We just send that in as empty, and then you can see our librest just stores those in local variables for use later. So now we know how to configure the REST library to communicate with the Stripe API. Let's take a look at how those configuration values are put to use. So if we scroll down, we can see a command here, librest request, and this is the main handler that our REST library defines, and it's a variant of the handler that we outlined in the slides earlier. It's essentially just an extended version. Takes a handful of parameters. The first one here, p method, that's the HTTP request method. That's the HTTP verb that we remember from earlier, so one of get, post, put, patch, delete, and so on. Then there's p resource, that's the resource name that we want to fetch, so that'll be used to build the URL and the API that we call. Then there are the query parameters, so these are any parameters that we want to include in the query string. Then there's pBody, that's any parameters that we want to include in the request body. After that we have any headers that we want to send, in addition to the base headers that we'll define. And then there's an optional user callback which we can use to make this handler asynchronous. So let's take a look at how it's actually implemented. So the first thing we do is we generate a unique ID for the request using LiveCode's UUID function. This ID is used to reference the request throughout its lifespan. Next thing we do is we build the endpoint or the URL for the resource. So we build that based on the endpoint for the API. So if you remember, that's configured in librest configure. So that's API, in our case that'll be api.stripe.com, then we add a /, and then we add the actual resource name, which we URL encode. We use an internal function here, librest URL encode RFC, which is an extended version of LiveCode's URL encode function. It just does a few extra bits and pieces to make sure that everything's encoded correctly. You can scan this handler yourself, but it's fairly straightforward. It just does some extra text encoding in, replacing with the appropriate escape sequences. But now we have the URL for this individual request. Now you notice that we store this in a dictionary of requests keyed by the request ID. When I talk about dictionary, essentially what I mean is a LiveCode array that's keyed by a string rather than an integer. An integer would be an array or a sequence. That's what we'd call a sequence or an array, and a dictionary is something that's just key value pairs essentially, i.e. it's keyed by a string. So we store this in the local variable sRequest dictionary, which stores all the individual requests that are currently being processed. Next thing we do is store any callback information. So that is if this handler has been requested with a user callback, we store the actual callback to call and the location to send that. So the calling function, the calling handler that called us, so we can send it to the appropriate location. We'll see how that works in a moment. Next thing we do then is build the query string. So we've been passed again a dictionary of query parameters, so essentially key value pairs to include in the query string. We encode that appropriately, so key value pairs, if you remember, in the query string are just key equals value and then ampersand. So we have an internal handler again, librest array query librest array to query string, so it builds our query strings array or dictionary into a string for use with the URL. So we just append that to the URL using after including a question mark and then the query string. This handler here, we can scroll down and see how it works. Again, it's an internal handler which you can scan yourself, and it's fairly straightforward. It just builds up the key value pairs separated by ampersand and equals. It's a fairly straightforward handler, but does all the tricky parts of the encoding the query string. So that's us built the query string, which we've just included in the request URL. The next thing we need to do is build the request body. So we need to determine the content type, the encoding type, which is based on the content type. Now you can override the content type for a particular request by including in the header, the content type headers, or if that's not set, then we can just use the core content type that we set up at the point of configuration, which we know is stored in this content type. And if you remember with libstripe, that's form, so we're form encoding all our request bodies, and we can see this here. Based on the encoding here, we perform the appropriate, based on the content type rather, we perform the appropriate encoding. So this is a nice little feature we've got here, else on LiveCode server object notification. That is if you're using a REST API which is built using LiveCode server, you can use LiveCode's array encode and decode functions to encode the bodies. The second option here we've got is JSON. So if we're using JSON encoding in our request bodies, we can use the merge JSON function array to JSON. And if we're using form encoding, which is the simplest one, which is what we're using with Stripe here, then we can just encode them as key value pairs, which works exactly the same way as the query string. It's just key equals value and separated by ampersand. Fairly straightforward, and you can take a look at the specifics in your own time if you want to see how that internal handler works. The second thing we want to do is build our headers that we want to include in the request. So first of all, we just pass in the user passed header, so that's the dictionary of headers that has been passed in with the call to the handler. We set that up in T headers, and then the next thing we need to do is include the content type in the headers. With that we're telling the server how we've encoded the body. So we know we determined that earlier with the body encoding, so we make sure we include that in the content type, and then we include the accept type in the header. So this is us telling the server how we want the values to be returned, or how we want the returned values to be encoded. So this is in this accept type, which we set up in librest configure, which we can see in here is JSON. So essentially this header here, the accept type header, which we're storing here, tells the server how we want the values that it returns to be encoded. So in this case with the Stripe API, we'll have all the values returned as JSON encoded. Next thing we want to do is include any authentication headers. Now, we're not using any tokens with the Stripe API, so we can ignore this first section. S token is not set, but S username will be set. If you remember, S username is our secret key and S password will be empty. So we build up our HTTP basic authorization header, which is just the string basic followed by a base64 encoding of the username and the password. And make sure and also one thing to be aware of when using LiveCode's base64 encode functions is it will include returns, so make sure we replace those with empties just to make sure it adheres to the HTTP basic auth standard. And finally, our headers is just an array at the moment. We want to convert that into a string for including in the request, so we just use LiveCode's combine function, which will just take a key value pairs and separates them using colon and return. So it will just be header name, colon, header value, and then return header name, header value, header name, header value, each on a new line separated by colon. So that's just got the core of the request constructed. Now we need to actually send it. And as we mentioned before, we use TSNet's handlers. These are the async handlers, so they exit immediately and send a callback when completed. So the handler we use is specific to the actual request verb that's been passed in. So we use TSNet if the request verb is get, post, and then the upload, which is when put is used, custom upload when we want to use patch, we specify the patch method, and then custom when we want to use delete. Now notice these all pass through the request ID. That's the unique ID we used for the request, the URL that we built earlier for the request, any headers, and then if we've included any body, it will include that, and then our custom callback, which is an internal callback within our handler. So we can go and look and see what happens in LibRest response callback. So this is a standard TSNet callback signature. You get the unique ID for the request. So remember, we generated a unique ID using LiveCode's UUID function. The result code, so that will be the HTTP result code, 1 of 200, 300, 400, 500, and so on, and then some extra information about the bytes returned in the curl code, which are internal to TSNet that we don't need to worry about too much. But with TSNet, the first thing you need to do is get any data for the request and any error that happened, any error that may have occurred. So we can use TSNet retrieve data function to do that. And then the next thing we do is want to get any headers that the server returned. So we can use TSNet retrieve headers function to get any headers. So now we have the actual body data sent back and the headers sent back. So this little part here we can really ignore for the Stripe API, but what this does is check to see if there's any authorization information in the headers sent back from the server. But since we're not using tokens for authorization in the Stripe API, we can ignore that. We're just using a username and password, which is set with all requests. But the next important part for us is to check the content type returned by the server. So this is the server telling us how it's encoded its response, which we know will be JSON because we told the server that we expect the response body to be JSON encoded, but we double check this by checking the content type header that the server responds with, and if it's application JSON, then we use merge JSON to decode it into a LiveCode array. Likewise, if it's application else on, that's a nice little feature that if the server returns LiveCode encoded data, we can use the array decode function, but that will be unlikely that you'll see that out in the wild unless, of course, you've built the API yourself using LiveCode server. So the next part of the response handler is to deal with the actual result code that we've been returned by the server. So what we do is check if it's a 200 result code, then we know it's been a success and that the server has sent through a response body that we can parse and send back to our client that's called function. And if it's not a 200 response code, then we know it's an error, so we need to parse any error, which can be one of two places. It can either be in the TError variable, which we got when we called retrieve data, or if there's nothing there, then we know that the actual error data is included in the response. And then what we do is we store that in our request dictionary for the request ID. So we've either got a response or an error. And this is when we want to return a function synchronously, that is when there's no callback for the specific handler. If there is a callback, then we make sure to dispatch that callback to the appropriate place. So we dispatch the callback name to the calling context, and then we just do some cleanup. And one thing that's important to do when you're using TSNet is to make sure we close the connection based on the request ID, because we're now done with that, and that will free up any memory that's used that's associated with that connection. So if we go back to our librest request handler, we notice that we've got the wait command here, because we're mainly functioning in the blocking or the synchronous context. So what this does is it waits until we've either got a response or an error value. So we just wait until that's stored in the request dictionary for this given request. So if you remember here, if it's once we get to this point, we store a response or an error in the request dictionary based on if the request returned a 200 code or not. And here, the original calling handler is just waiting away until there's a value there. So basically it's going to block until we've got a response from the server. And when we do have a response from the server, we can now return this back to the calling handler. So you might not have seen this LiveCode syntax before, but you can either do return for error or return for value. When you use return for error, that means the result will be set, and when we do return for value, that means the it variable will be set. So this is essentially just determines if we return error data, and the calling handler can determine if it's an error by checking the result, or the calling handler can check if it's a success by checking the it variable. The part of the handler that I touched on briefly is if a user callback has been passed. Now we won't be using that in this particular example, but it does allow us to make the librest request handler asynchronous. That is, it will return immediately, and then it will dispatch a callback when the server has returned a response. In this situation here, if p-user callback is empty, that means we're functioning synchronously, but if it's not empty, then we're functioning asynchronously, and what we'll do is we'll turn the request ID to the calling context, and the calling context can then cancel that request at any point using librest cancel request, which is a nice feature. It can just cancel it if for example the original request is no longer required. They're going back to a user has clicked back to a previous screen on the API, the UI stack. We can cancel it. But then here we can see that if the callback is empty, it will put that information into the request dictionary. But if the callback is not empty, that is, we have a callback to send, then we'll dispatch that callback to the calling context, and the user can then handle that callback function appropriately and update the UI. But as I say, we're not really using that variant here. We're using the simpler linear style with a blocking, essentially what is a blocking request, but using wait with messages, which means our UI will continue to function nice and responsively. So that's pretty much the main of our REST library. You can see it just defines one main utility handler that allows us to access a single REST API resource, along with a couple of configuration handlers that allow you to set it up for a specific REST API. So let's take a look at how we might actually use the library. Moving back to our UI stack, if you remember on our first card here, we display a list of customers that's stored in the Stripe API that is filterable by an optional email address. So let's take a look at the Stripe API to see how we might actually fetch the customer list. So if you remember, down the left hand side we have the list of all the resources that the API has to offer, and down here we can find customers. Here it is here, what we want to do is list all customers. So you can see that this is a GET request, and the endpoint is customers, and it takes an optional parameter. Now, because this is a GET request, the parameter will be the query string, and that's the email. So that essentially correlates with what we saw in our UI stack. We pass the optional email there. And let's see what it returns. It returns a dictionary with a data property that contains an array of up to limit customers. And the customers will be a customer object. So limit is an optional parameter that we can pass in to limit the number of customers returned. But in this case here, we just ignore that. We're really only concerned about the email here. So let's take a look at the customer object, because we know that's what this returns in the data property of the dictionary. So the customer object has a whole bunch of attributes for each individual customer. So its ID, its address, which has additional child properties there, description, email, name, phone number, as well as a whole bunch of other attributes. So as you can see, this will be returned as JSON. This is the actual JSON structure, but because we're using merge.json to decode it into a LiveCode array, you can just access these directly as a LiveCode array with an ID key, an object key, address key, and so on. So let's move over to our Stripe library to see how we'd actually call the customer list function. So here we've got a handler called libstripe list customers. It's a command, and we have one parameter, which is an optional parameter, which is the email that we want to filter them by. So first thing we do in this handler here is build the query parameter, or the query dictionary. Then we know this is an optional one, so we first of all check to make sure the email is passed, and if the email is passed, include it in the email fields. So that corresponds to what we expect here. The email parameter is just named email, so we just include that in the query parameters there. And then we know that it's a GET request, as we see here. It's GET, and the endpoint is customers, so we can just say lib rest request. It's a GET request, the endpoint or the resource name is customers, and these are the query parameters that we want to include. And then we need to check the result. So if the result is not empty, so if you remember before, we return for error, and that will mean that the result is set. Then we know that that's an error, so we just return that again exactly the same way. Return the result for error, and if it is set, so that's when we do return for value in lib rest request. We know then that's success, and we return that for value. So notice how here we return the data parameter of the it variable, which is a LiveCode array, and if we remember here, it returns a dictionary, and the data property contains an array of up to limit customers. So effectively, that's our customers array that we're returning here. So we're not getting really concerned about any of the other values that are returned there, which details the specifics of it. We only really care about the data, that is the array of customers. So this is essentially what our handler does. It takes an email address, calls the endpoint, which is get customers, and returns an array of customers if it's successful, or an error otherwise. So let's return to our UI stack to examine how we might actually call that handler. So let's take a look at our customers card script, and we can see that on open card and also on mouse up when the search button is pressed, we call the refresh customer list handler. And the first thing the refresh customer list handler does is it sets the U visible of our spinner group. So you can see what that does here. This is our spinner group here, and it's quite an interesting little group, so let's examine it. So from in the message box, what I'll do is I'll just call that command, set that property, set the U visible of group spinner. If I could spell true, that would help. And you can see here our spinner group now sits on top of the card. And the spinner group does a couple of things. First of all, you can see there's a little spinner object here, which is just the spinner control, LiveCode's default built-in spinner control, and that tells the user that something is going on. That is, there's some processing going on. And then secondly, there's this grey background rectangle, and since that rectangle is opaque, it completely locks off any user interaction. So let's have a quick look at the code for the spinner group. And it's fairly simple. You can see it's got this one set prop, set the UVisible, and if it's true, then we set the visible of the group true. We also do a little bit of resizing work to make sure it's at the front of the card and size to the size to the appropriate dimensions for the current card. And then if it's false, we just hide it. So it's relatively simple, but it provides quite an important function, which is telling the user that processing is going on and not to be concerned that the UI stack is frozen or anything like that. And it also blocks off user interaction. And if you remember, because we're using wait with messages in our LibRest stack here, wait with messages, and using TSNet's asynchronous handlers, that means that everything will function smoothly and the UI won't freeze. So the spinner will continue to spin nicely, and that's quite important there. So we can hide it there by setting the UVisible to false. Returning to our card script, we can see that what we do next is call libstripe list customers and pass in the field search term. So libstripe list customers, that's our handler that performs customer listing, and it takes in the field search term, which in this case is this field here, and that will just be the email address that we want to filter on. Then once that handler returns, so we know that this is a synchronous handler, that is, it will block until the result is returned because we're not passing in a user callback. Then we can either check the result. So if the result is set, then we know that there's something's gone wrong and there's an error, and we can display the error with this handler here. And if not, then we know it's successful, and then we can set the DG data of our data grid to the information that's stored in it. Now we know we can just set the DG data directly because it is just an array. If you remember our list customers, on success it will return an array or a sequence of customer objects. So it's just an array, which is exactly what the DG data property expects. This is just our data grid here, so we can just set that appropriately directly, and that's a fairly straightforward data grid process, and you can check the code to see exactly how it works, but essentially we just display the name and the email address for the customer. So the handler here, libstripe display error, that's a handler that's present in our Stripe library, and all it does is something very simple, which is calls the answer error command, and it displays the human readable error message. Now if you remember, going back to our Stripe API docs, the errors have a standard format, which will be an object with associated type code and so on, but the one that we're interested here is the message, the human readable message, which we access here in the error object, and then the actual message. So this demonstrates that the data returned by Stripe API has been decoded from JSON into a LiveCode array, and then we can access the error object and then the human readable message and display that in an answer command. So it's all very straightforward there. We perform the listing, and if it's successful, we set the data grid data to the array returned. If it's an error, that is the result set, then we display the error using a LiveCode's answer command. Next, let's take a look at how we might add a new customer. So we've got a new customer card here, and we just have fields for the name and the email address. So let's return to the Stripe API for customers and see how we might go about creating a new customer. So here we are, create a customer, and on the right hand side here we see that it uses post as the HTTP method and the same customer's resource name, and it takes parameters here. So these will be in the request body since it's a post request, and it takes an assortment of parameters, but we only had email in our, if you remember, our email in our stack and the name. You can include extra additional parameters such as the phone number, its address data, shipping data, other things, but for us, for simplicity, we just include the name in the email, which is exactly what we've got in our stack here. So let's take a look at how we might implement that in our Stripe API library. So we go scroll up, we have a handler here, libstripe create customer, and as expected it takes two parameters, name and the email. We create that in a dictionary, so name and email as a pair, as key value pairs. It's a post request, we post it to the customer's endpoint. We don't have anything in the query string since there's nothing there, but we do include the request body, which is their name and email, and that gets sent off to Stripe via the LibRest request handler. So as you can see, it's fairly straightforward. Again, the LibRest request does all the hard work. We just then need to process the result, and the result, let's see what it returns. It returns a customer object. So it's exactly the same as we saw earlier with the list one that returns an array of customer objects. This just returns a single customer object for the newly created customer, or of course if there's an error. So let's take a look at that in action. So let's add me as a new customer, and let's put an invalid email address just to see what happens with errors. So as you see here, it's using answer, we're displaying the error, and this is the error that Stripe returned in the human readable format, invalid email address, Michael. So let's take a quick look at the new customer card to see the code here. So you can see that on the create button here, we call create customer, and it's very simple. It's almost identical to our list customers card. We display the spinner to make sure the user knows something's going on. We call libstripe create customer with the name and the email from the fields, and then we handle if it's an error, or if it's a success, we go back to the customer card where the new customer will be displayed. So let's just add a correct email address. Click create, goes back to it, and there we can see the new customer has been created. And we can actually double check that by returning to our Stripe dashboard. If we refresh this, we can see, oops, my network connection is a little slow at the moment, but we can see the newly added customer there that's been included in the customer list. So this here reflects exactly the same as what we're seeing in our Stripe customer list. Now let's take a look at how we might examine and edit an individual customer. So when we double click on an entry in our data grid, that allows us to edit a specific customer. And let's just take a quick glance at the data grid code to see what we do there. We use our data grid template for the individual row script, and you notice that on mouse double up, we set the uCustomer ID of the edit customer card to SID, and then we go to the edit customer card. SID is a script local variable that we've stored in the fill-in data handler here. The command it's called. We know that pdata array is just passed in, that's our customer object, and each customer has a unique ID. So we just store that in a script local variable for future reference, and then we pass that on to the edit customer card upon double click. So we double click here on Michael. We can see that it displays my information, my name, my email, my cards and payments. So let's take a quick glance at the edit customer card script to see what's going on here. So first of all, we've got this set prop here, uCustomer ID, which is exactly what we called from our data grid, and that takes the unique ID of the customer that we currently want to edit, and we just store that in a script local variable. And then if we go down to fetch open card, it calls the handler fetch customer, which we can scroll down to here, and it's again takes a very similar format to our previous UI handlers. First thing it does is it makes sure that the spinner is visible while we're doing some processing, and then it gets information for that specific customer by calling libstripe get customer. So let's see how we actually might get information from the Stripe API for a specific customer. So if we go back to our customers, and down here we can see retrieve a customer. And this is a get request. We call the customer's resource, but then we pass a specific ID for the customer. So that's the customer ID that we want to fetch. And again, it returns a customer object, so much like the create endpoint, it returns a customer object which we can then display. So we call this through our libstripe API, libstripe get customer. So let's take a look at what that does. So libstripe get customer takes our customer ID, and exactly as we expect, we call librest request. It's a get on point, but this time instead of just customers, we need to pass in the specific customer ID in the URL. So that's essentially what our API is telling us here: customer, and then the specific customer ID. So customer/ID. Then we just call that and return the result if it's an error, or if it's a success. And then exactly as before, we can display the error if that went wrong, and if it's a success, then we know it is a LiveCode array which represents the customer object. Here we only care about the name and the email parameters, so we store the name and the email in the two fields that we have, name and email there. The remainder of the handler here, you can see, deals with fetching the customer's cards and their payments, but let's ignore that for the moment and first of all focus on what happens when we actually want to edit a customer. So here we can see we can change the customer name and email address. So let's add my surname, not LiveCode, to my email address. And then we have an update button here, so let's just quickly check through. When update is called, we call update customer. So let's take a little look at that handler here. Again, it's very similar to the previous ones. We display our spinner to make sure that the user knows something's going on, and then we call a handler in our Stripe library, passing through the customer ID and then the updated name and the updated email. And likewise, we display any error, or if it's a success, we return back to our customer's card. Let's just double check to see how that works. So we've updated my email address, click update, spinner appears, all has went well, and you can see my updated email address there. So let's take a look at the Stripe doc to see how we might update a customer. So this is post, that's our HTTP verb. The customers is the resource name, and like with our fetching an individual customer, we pass in the ID of the customer in the URL. And then the request body will have a whole selection of parameters available that you can update. We are really only interested in the email and the name as before, and then likewise with the retrieve a customer, it returns the updated customer object or an error if that failed. So let's quick look at our Stripe library to see how that works. So that's libstripe update customer, and if you remember from our card script, we pass in the customer ID, name and email that we've pulled from the UI. Customer ID, name and email. We build our request body to include the name and the email. As I mentioned before, you could include any other fields in here, but we're really interested in the name and the email. We know it's a post request, customers, and then the customer ID is the resource name, so that's just customers / our unique ID. There's no query parameters here, but we do have our request body, which is our updated details, and then just like before, we return the result if it's an error, or it if it's a success, but here we just ignore the return value and return to our previous customer listing cards, which will now display our updated customer. So there you can see it's all fairly straightforward for managing an individual resource. We scan back to our Stripe docs. We detail a get endpoint for fetching all the customers, a get endpoint for fetching an individual customer with a specific ID, a post endpoint for creating a new customer, and a post endpoint for editing a customer. And then there's this final endpoint, delete, for deleting a customer. So let's take a look at our UI stack to see how we might actually do that. So here in the top right, we've got a little X button. And if we check a look at our mouse up command, that's delete, and we call delete customer here. And again, this is very similar to all our previous commands, except we've just got a little warning answer here. Let's see how that works. Are you sure you want to delete this customer? Yes or no. If it's yes, or if it's not no in this case, we do exactly the same as before. We set the UVisible of our spinner to true to make sure that the user knows that the UI stack is doing something, and then we call libstripe delete customer. So let's take a quick look at that. Again, it's very simple. It's just a delete request this time, and we pass in the customer ID in the URL or in the resource name, which is exactly what we expect in the Stripe docs there. We can double check this with delete a customer here, delete customer, and then as before just return any values if it's an error or a success, and exactly as before in our UI stack, if an error has occurred, display that error, otherwise we can just return to our customer's card. So let's just do that, click yes, delete's in process, and then if it's successful it should hopefully return to our customer's card with our that customer's with the updated customer list, so that previous customer, that was me, Michael, has now been removed. If we return back to our card to edit a customer, you can see that we also have a list of cards and a list of payments. So let's take a look at cards next, and we go back to our fetch customer handler. You can see that we call libstripe list customer cards and pass in the customer ID. So let's take a look at the Stripe docs to see how we might fetch the list of cards mapped to a customer. So much like with customers, if we scroll down, you can see a card section here, and we've got the summary of endpoints here, and you can see here now cards are a sub-resource of customers, so we can fetch customers / customer ID / sources, and that will return all the sources, in this case cards, mapped to the specific customer with the ID. So let's take a look at how we list all cards. So the important thing to note here is that we extend, or we pass a query string here, object equals card. So Stripe doesn't create a specific resource for cards. It just has a generic sources resource, and we want to fetch the card resource. So there are other types of resource that a customer can have mapped to them. There's other payment methods like bank accounts and such that a customer may have, but we're only really interested in credit cards at the moment. So let's just go back there, list all cards. So what we need to do is pass object equals card in the query string, and then that will return the list of cards stored on the customer. So this will be an array of cards. We know that is similar to the way the customer's list works, which will be a card object which has a whole bunch of parameters mapped to them, things like the expiry date, the last 4 digits, and so on and so forth. So let's scroll back to our little Stripe library and look at that handler there that we called from our UI stack, libstripe list customer cards. As per our UI library, we pass in the customer ID as the main parameter, and this time we put card into the query parameters. So this maps up to what we have here. We want to pass in object equals card, so we put card into tQuery parameters dictionary object, and then we pass that through to librest request. It's a get request, customers / customer ID / sources. That's our resource. There you go, customers / ID / sources. That's our endpoint that we want to fetch, and then we pass in our query parameters. This time card is our object type, and just like before, we return the result if it's an error, and we return the it value if it's success. And like with the list here, we can see it returns, like with list customers, it returns the card list in the data parameter. So that's all we're really caring about, is the card list, rather than any of the extra meta information that's returned there. So we just return it and then the data key, and then much like with the customer list, we just set the DG data of the card group to display the individual cards. Let's take a quick look at what is going on with the data grid there. So there we set all we do is we store the brand, so in this case Visa, so the last 4 digits, it's the last 4 digits of the card, and then some expiry data. So we just display that in a text field which corresponds to the information that we receive in the card object. That is the brand there, Visa, the expiry data, and the last 4 digits. That's exactly what we get in the data array, or the LiveCode array that represents the JSON data that's returned by the Stripe API. So that's fairly simple, and it's much like what we've got with the customers listing. We just display the card listing, but this time cards are a sub-resource of a customer, so we fetch them slightly differently. So let's take a look at how we might go about adding a card to a customer's account. So we click the plus icon here, and up pops the option to enter a card number along with the expiry date and its CVC code. So let's take a quick glance at the Stripe docs for creating a card. So create a card, much like we would expect, it's a post request and it's customer's ID and sources. So we're creating a new card, or in this case a new source technically, for a customer with the given ID. And this time the source is a token, and it specifically says a token like the one returned by Stripe.js. Stripe will automatically validate the card. So this is a little different to what we've got here in our UI stack here, where we can include a card number. We're running Stripe in test mode, so we can just include some dummy data for the card number there, the expiry date, the CVC, and also the zip code there. But it says, rather than passing through the card number, the expiry date, the CVC and the zip code, we pass through a token. In order for your app to handle credit card details directly, you need to become PCI compliant. Now, becoming PCI compliant is somewhat of a long and lengthy process and requires jumping through quite a lot of hoops, but fortunately Stripe provide a way around that. They provide a JavaScript library called Stripe.js, which essentially means that their JavaScript library, can deal with the cards, handling cards directly. You don't ever have to touch them themselves, and you only ever deal with tokens. So what that means is, here on our LiveCode stack, we've actually got a browser widget which uses Stripe's JavaScript library to extract a token from a card. Now, I won't go into the specifics of exactly how this works. You can take a look at the source code yourself, and also it's worthwhile referring to Panos' talk on the browser widget and how you can integrate that with your LiveCode stacks. But what is important here is that we're able to extract a token, which is what we want here when creating a card, from the information, the credit card details that are entered into the browser widget. And here we have a callback handler on token updated. That's called by our browser widget when a customer token has been updated and created. And here we simply call libstripe create customer card, passing through our customer ID and our new token. So if we take a look at that handler here, libstripe create customer card, as expected, the customer ID and token, and we push our card token details into our dictionary here, which will be our request body, and we pass in our customer ID in the resource name. And this is a post request, so it's exactly as per the docs. It's a post request to customers/ID/sources, with the request body including a token, which is one returned by Stripe.js, which is exactly what we've got here. And that's what we post through, and it should create a new card. And if it's a success, again, we return the success value, and if it's an error, we return the error value. So exactly as before, we display any error there if it's an error, and if it's a success, we return to the customer card, which should display that newly created card. If we click create, the spinner displays, and then success, we should return to the customer's card, and there we can see a newly created card. That's exactly the same details as the one I created previously, but that's the newly added card to Panos' customer account. So hopefully we're beginning to get a bit of understanding of how REST APIs work, how the Stripe API works, and also how our library stack, specifically our REST library stack, makes it nice and simple for accessing APIs from LiveCode directly. So the final part of our customer's card here is the list of payments. This is payments taken from a specific credit card or a customer. So let's take a look at the Stripe docs. Now, you may notice there's a few sort of payment options, but the one that we're interested in here specifically is payment intents. You might need to do a little bit of searching around and reading, but here we can see that a payment intent guides you through the process of collecting a payment from your customer. So that's exactly what we want here, collecting a payment. Another thing you might notice here is that payment intents are a parent resource rather than a sub-resource of an individual customer, and that's because you can take payment from a card without it being mapped directly to a customer. So it's just a little way that the API is arranged. It's a little bit different, but for our purposes, we're mapping payments directly to a customer. So the first thing our library stack does is list all our UI stack is list the payments mapped to a customer, in this case Panos. So let's take a look at this. List all payment intents, and as we'd maybe expect, it's a GET request that's typically used for listing, and the endpoint is payment intents, and it takes an optional parameter here, which is the customer ID, which is exactly what we want. We want to return the payment intents, or the payments here, for an individual customer. And if we go back to our card script for editing customers, we can see that when we fetch a customer, we do libstripe list customer payments, pass our customer ID, and if you go back here to our Stripe library, libstripe list customer payment, we pass in a customer ID, and we pass in the customer ID as a query parameter as per the Stripe docs, which is what we do here, and we call get on the payment intents endpoint, and then return the values either for an error or for success. And here, like all the previous lists, requests in Stripe, it's the data parameter of the response object that we're interested in. That is the array of payments here, and much like with our customer and card listing, we set the DG data of our payments group to the value returned, which we know will be an array. Let's take a quick glance at our data grid script to see exactly what that does. So here we see on filling data, we do a little bit of pre-processing. We create the currency string, whether it's pounds, dollars or euros, put that into a currency symbol, we convert our amount received into T amount, and we convert the date into a date. So let's take a look at what the payment intent returns, because we know that it's a payment intent object here. That's what it returns as per the description. And so the first thing we notice that the amount is what we want, and this is in the smallest currency unit. That's important to note here. So 100 cents here maps to $1. So that's corresponds to what we've got here. We convert T amount, we divide it by 100 to make sure that we get it in dollars or euros or pounds rather than in cents or pennies. Then we also do some conversions from the 3-digit currency code. That's under currency, which if we scroll down here, that's a 3-letter ISO currency code, which is what we handle here: GBP, USD, EUR. We could handle the other currency codes there, but we only handle those 3 for the purposes of demonstration. For the other ones, we just display the 3-digit currency code, and then the created, we convert that from the seconds to the long date. So if we scroll down and see if we can find created, I think that was a parameter here that was at the end. Yeah, here we go. So it's a timestamp, and we know that's a timestamp measured in seconds since the Unix epoch, so we can use LiveCode's nice convert command to convert that from the seconds to the long date, which is displayed here as Thursday, July the 1st. You can convert it as however you want, but then we just display it in the data grid, in the field within the data grid, for nicely in a human readable format for that individual payment. So that just leaves us with the final part of our UI stack, which is to create a new payment for the customer. So let's add a new $100 payment to Panos. Click create. Spins around. My internet connection's a little slow here, but there we go, a new $100 payment mapped to Panos. So let's take a quick look and see what the create payment, or the new payment card, is doing. So on the create button being clicked, so if we go back to the card here, on the create button clicked, on mouse up, we call create payment, and it's much like all our other handlers there. We display the spinner, then we call our libstripe library function, passing through the customer ID, the currency code that we want to use, so GBP, euros, US dollars. We could of course include the other currency codes there, but we've just limited to those 3, and then the amount that we want to pay. and then handle the result. If it's a success, go back to the customer card. If it's an error, display the individual error. So let's take a look at the Stripe docs to see how we might create a payment intent object. So, as you'd expect, it's a post request, as it follows the pattern with REST APIs and exactly what we've seen with all the other API endpoint with Stripe for creating something. The payment intent is the resource name, and then the parameters that we pass through. The amount, that's the amount required, and again, like with the value returned, that's in the smallest currency unit, so we need to multiply that by 100. The currency code, that's our 3-letter currency code there, and then confirm. This is a parameter here that we set to true to confirm this payment attempt. So essentially what this does is if you set it to true, then it will immediately try and take the payment. Otherwise, if it's left as empty or set to false, it will set as pending and can be confirmed at a later date. And then another thing that is important here is we want to pass through the customer that we want to map this payment to, so we're using a specific customer rather than an individual card. So let's take a look at our libstripe create customer payment handler. So as we see, it takes customer ID, currency code and amount. We put the customer ID into our request body dictionary. We put the amount, being careful to multiply it by 100, and the currency code. And then we set the confirmation flag to true to make sure that we take this payment immediately. And then we pass this here, the payment details dictionary in the request body. And it's a post request to the payment intents endpoint, and then we handle the response exactly the same way as we have done with all previous requests, and that should then if it works, we should see that in our list of payments mapped to the Panos' customer object. So that concludes our walkthrough of our Stripe REST API integration. As you can see from the Stripe API docs, there's a whole lot more that we could have wrapped, but hopefully this provides you with a good introduction to REST APIs and some pointers as to how you might go about integrating them into your own LiveCode stacks. It starts from understanding that REST APIs are a set of guiding design principles that use HTTP to provide access to managing resources. We then walked through how you might create a generic REST library that accesses REST API endpoints, and then we created a specific library for Stripe that allowed us to access and wrap the specifics of the Stripe REST API, and we then used that library in our own stack, making sure to provide user feedback when necessary.